Hi everyone, my name is Phil. So today we're going to be learning about ARKit and how to create complex AR experiences in iOS and Apple platforms. So I'm a first year CS major, and can anyone tell me, have you had any AR experience before, experience with ARKit or iOS whatsoever?
iOS.
So someone did like some stuff. So we're gonna cover the basics of ARKit today. I'm gonna talk about what is AR and ARKit. We're gonna cover some theory about the framework. Then we're gonna do some live coding where I'm gonna show you how to create an actual AR app and place virtual objects onto real surfaces. And then I'm gonna talk about next steps, or like what you can do where you can learn more about ARKit. So augmented reality is basically placing virtual objects on in real world. It's basically tracking your device in a physical environment and creating real anchors on those objects. So this is an example. We're gonna do something similar today. You can see like the real output from the camera on the left and what the user sees. What ARKit provides is basically, it handles everything in the backside of this for you. So it updates the lighting automatically, it updates the position and rotation of your device. So ARKit and what it provides to developers can be broken down in 3 separate parts. The first and one of the most important ones is tracking. It provides advanced world tracking where the initial position of your device is going to be expressed as a vector 000, and it's going to be expressed in real world units, so you don't need to convert between anything. It's going to use visual inertial odometry, which is basically combining the input from camera and motion data to estimate the location and rotation of your device in real time. All of this is handled behind the scenes for you. And of course, there's no external setup required. ARKit is supported by all devices which have the processor of A9 or newer. So these are all devices starting with iPhone 6s and iOS 11. So you don't need to buy any external stuff. You can just create your app and publish it on the App Store, and millions of people are going to use your app, are going to be able to use your app if you advertise it, of course. So the next layer of this is scene understanding. Basically under the hood, ARKit runs neural networks to provide plane detection. So starting with ARKit 1.5, you can detect both horizontal and vertical planes. You can also detect images such as QR codes, for example, or you can detect 3D objects. And you can create your experiences around those objects. It also provides heat testing functionality. So for example, if you have a virtual plane or surface and you want the user to be able to tap on screen and basically place some object on that spot, ARKit is going to provide a simple method to do that. So you don't need to do some complex mathematical manipulations to handle that. It's going to be handled for you. And of course, ARKit also provides light estimation, which we're going to see in action today. There's no setup required for that. It just comes out of the box for free. And the next layer is rendering. It's easily integratable into any renderer of your choice. So for example, if you have used SceneKit or SpriteKit before, those are iOS frameworks for rendering 3D and 2D objects respectively. You can use those, or if you prefer to use Metal, you can use that as well. To place your virtual content into the UI of your app, ARKit provides AR views, so that's AR scene view and SceneKit view and AR SpriteKit view, so that you can use the same syntax that you would use in your SceneKit projects. And of course, you can do custom rendering as well, but that's more advanced, and there is a separate Metal template in Xcode if you want to go into that. So, as I said, ARKit handles all the processing for you. Then you can use the rendering engine of your choice, such as SceneKit, SpriteKit, or Metal. And then we have the application layer, which is basically your app that can utilize all those functionality for free. So what does ARKit use under the hood? Two main components are AV Foundation and Core Motion. So basically it captures images, which is the most important for understanding the world around you. And then there is Core Motion, so that we can capture the motion of the user and estimate their position in real time. And as we'll be able to see today, it's really accurate. So if you have used your iPhone a lot, you probably know that there is an app called Measure, and it's able to pretty accurately measure distances in real world if you tested it. It's actually based on ARKit, and it would be really easy to implement. So basic structure of ARKit classes would look like this. So we start with an AR session configuration, which is where we specify what we're going to be using. So for example, I want to use a standard world tracking, or I want to track horizontal planes or surfaces. Then we create a AR session object and run it with a specified configuration. And it's going to create AV capture session and CM motion manager for you without any external setup required, and you can utilize those to capture the data you need and do any external processing. AR session will then output AR frames at a rate approximately 30 objects per second, even more on newer devices. The way you can access those is using current frame property on the AR session object. So when we create our AR session configuration is where we specify what we're going to be doing with our session. There is a base class, which is AR session configuration, which provides 3 degrees of freedom tracking, which is basically just the orientation of your device. So if you use this, you will need to do everything manually, like except for tracking the device's rotation. What is more interesting is the subclass of AR session configuration, which is AR world tracking configuration. And it's gonna provide you with 6 degrees of freedom tracking, which is both the position and rotation of your device, as well as different 3D anchors based on the advanced scene understanding. So this is a simple way of creating our configuration. So for example, we want to check if our advanced configuration is supported and otherwise use the base class. So this is pretty straightforward. The way we manage our AR session is pretty easy too. So we just need to run it using our configuration object. We can then pause it, for example, when the user exits our app or goes to Springboard, or I don't know, like something happens that requires us to pause our experience. Then we run the same command with the same configuration object if we want to resume the session. If something unexpected happens during our session, we can always reset it, and it's gonna start from the same position, and your position is gonna update to 0, 0, 0. The way we handle updates is we can use those AR frames directly and handle all of the processing ourselves, what's more easy is to use the session delegate. So we can set our own custom class to be the delegate of the AR session. And we can use the did update and did fail with error methods to handle updates and errors, respectively. Each AR frame object, if we choose to use that, includes the output from the camera, output from the motion manager, and the location of the device. I'm gonna go into the coordinate system in a second, but what it also includes is all of those anchors represented in yellow. Those are real 3D positions and rotations of each point that ARKit was able to detect, such as, for example, the table surface. So what those objects are, they are AR anchors. Those are real 3D objects with real world position and rotation so that you can use it, for example, to set virtual surfaces. We can add or remove our own anchors from the session, and they're going to be captured and they're going to be updated using the ARKit scene understanding engine. And of course, we can use the delegate methods to add, update, or remove those anchors and catch those events as they happen. So again, this is the base structure of ARKit. This is basically all you need to know to be able to create really great experiences in AR. So the way world tracking works, as I said, is that you get both position and rotation vectors from your session. It's important to note that all of the distances are metric, so they're measured in meters, not in feet or anything else, not in some random units. Those are actual real-world meters. So if you have a 3D model, which is 28 units in width, for example, that means it will be 28 meters in width, which is a lot. So you need to adjust that. And your origin is always going to be the starting position and rotation of your device. Of course, ARKit will keep track of all of the feature points for you. So coordinate system, it looks like this. This is going to be our y-axis, which is not the same as you would use in math, for example, but this is just the way it works. So for example, if I initialize my session with the camera looking that way, that means if I choose to place an anchor at, for example, 0, 1, 0, it means it will be here. So it's going to be above, not like to the left or to the right of the user. It's important to keep those differences in mind. So these 4 lines of code is basically how you initialize your session. So you just write those and you're good to go. You have your AR experience. So this is all we need to do, and I'm gonna demonstrate that in a minute. So if you choose to do more advanced tracking, you're gonna have to keep in mind that CM Motion Manager is updated more frequently to keep up with changes in the position and to allow for more customized experience for the user. So if you're trying to assume that those are happening at the same time, just check that. So before we start with our live coding, I'm gonna ask you a question. So For example, if a node in ARKit with a position of STN vector 3060 is placed in our session, where is it going to be placed? Like, what do you think?
C?
C?
Yeah.
Okay. Yeah, that's the right answer. So it's important to keep in mind that the positions are going to be metric always, and you cannot use different units at all. And it's important to know that you can use SceneKit or SpriteKit APIs as you wish in ARKit. So when we initialize our session, it's important to know that ARKit is gonna start with the limited capability, because we just don't have sufficient input data to process. So what you're gonna do is you're gonna want to ask the user to move around a little and gather some feature points, right? And iOS provides a AR coaching overlay for that. So it's just a Viewcontroller that you can present to your user when you're doing that processing. When we have gathered enough feature points, it's gonna go to normal. If at some point the user just stares at a wall or something, or just covers their camera, the session state is gonna go to limited. And then if they start gathering those feature points again, it's gonna go back to normal. In the sample,
Can you explain why looking at a blank wall is not good?
because it's just gonna be a plain color to the ARKit, and there is not enough depth to capture it as well. So it's not gonna be able to understand it in context, right? Since it also needs to capture the estimated distance, right? There's just not enough data.
So you need services that with different distances from you.
So for example, if you want to detect a wall, for example, it's important that the user will have some context, like a table placed near that wall, so that it's not just plain color, because it's impossible for the neural network to determine if that's a wall or if it's just, a sheet of paper or something. So in our sample project, we're not gonna handle that ourselves, so I decided to simplify that a little. And there is a wrapper class available that will basically provide you with different properties and session states. And we're gonna update our label to the user to show the current state and give them instructions. So these are some delegate methods that I have been talking about. They are set up in our sample project, and I'm gonna talk about them shortly. And since you cannot really run ARKit on the simulator, you're gonna need to co-sign your projects to run them on your device. So let's get started. I provided a sample starter project on GitHub. You can just follow the link, or you can scan this QR code and go directly if you want to follow our progress.
This assumes you have Xcode installed.
Yeah.
Should I do that?
Yeah, if you don't have it installed, start it now. It's on the App Store.
You're in game for what, too?
Yeah.
It just takes some time.
It's like 6 gigs.
That's a lot.
Yeah. It'll take half an hour.
What is it?
It's like the environment, so it's on the screen right now.
Oh, I see.
That's the environment in which you make iOS apps.
Okay.
IDE apps. So it's like Eclipse or IntelliJ.
It's like intelligent. Oh, that's it right
It's on the
there?
Mac App Store. Yeah, that's it. Huh?
Is everyone scanned the QR code? Do I need to wait? You good? like this. So I have provided a sample project. It includes 4 3D models that we're going to be placing. We're just going to be placing one. The idea of this project is that everyone likes morning coffee, and you just don't have time sometimes. And we're going to be placing our virtual cup of coffee on a table near us. So I think this app is going to have real success on the App Store. So we have our main storyboard where I have set up our basic Viewcontroller. We have this label that says, look for a plane to place your coffee, which is the default state that our app starts with. And then our whole screen is basically the AR SCN view, which means that it's an AR view that supports SceneKit rendering. So we're gonna be using SceneKit to render our objects, and we're gonna be using basically the same APIs as we would use now. We have our USDZ folder where I have placed some models, including our cup. If you open it, you can see how it looks. You can edit it a little. We also have a couple of model classes. This is the wrapper class that I have been talking about. It's called AR Session State, and it's gonna handle the changes to the AR state for us. And it's gonna update our label based on that. So for example, as soon as it's ready, we're gonna show click any plane to place your coffee. And if it's unavailable, we're gonna say the session is limited, please move around a little. Then we have the virtual plane class, which is basically the SceneKit node that is a wrapper around the AR plane anchor, which is a kind of an anchor that denotes a plane. So this is just for some simplification so that we don't have to code all of that manually in half an hour, but you can definitely look into that and see how it works. And then we have our Viewcontroller where I have set up the outlets. So our AR SCN view is gonna be called Scene View, and then we will have our status label that we're gonna want to update. So we will have our dictionary of the detected planes, since we can have multiple planes detected. And we're gonna have our session status that's gonna handle the output from the AR session state wrapper class, and we're gonna update our scene view accordingly. So what we're gonna be doing is we wanna set up our AR session right here in Viewdid load. I just added this for like nice rounded corners around the label. So the only thing that we need to do to get started with ARKit is basically set the views delegate and then create that AR session. Yeah, that's what I'm trying to do. Yeah. It's not what I wanted to do. Yeah, so this is the only code that we're gonna need. We set the delegate of the scene view to self, which means that we're gonna be handling the updates that come from our scene view. I also added this line for debug. We're gonna have a nice stats bar at the bottom of the screen to just handle the just see the FPS and the performance of our app. Then we're gonna create our configuration and set up some debug options so that we can see the origin of the world and we can see some anchors. And then we're gonna create our scene kit scene. If you have worked with that API, this is basically how you do that, and we set this scene to the scene view. Pretty straightforward. It's just an object. Just go ahead and remove this. So we have our model here in the USDZ folder. What we're gonna need is we create the URL object with a path to that model. So we have our cup.usdz here. We're gonna create a SCN scene from that, and we're gonna assign our mog node that I have created. We're gonna assign our root node from that scene to our mog node. So this is basically everything we need to get started. It's pretty straightforward if you're following in your Xcode. Next, we're gonna want to handle the event of the user reopening the app when it's been in background and then it's been relaunched or launched for the first time. So this is where we want to start our session. So this is where we start our experience. So as I showed in my presentation, we just create the AR world tracking configuration, and we set the plane detection property to horizontal, which means we're gonna detect surfaces such as tables. And then we just run our session with that configuration object. So view will disappear method handles the events when our view controller is gonna disappear from the screen, but hasn't done so yet. So for example, when the user quits our app, since we only have one view controller, when they go to Springboard and like launch another app and switch between apps, for example, what we're gonna do is we're gonna pause our experience. So this is pretty easy. We just call pause and we update our session status to temporarily unavailable. These three methods is where we're gonna want to add, update, or remove our planes. So ARKit is gonna only provide us with the anchors. They have rotations and positions in real world, and we will need to create that plane geometry ourselves. But this is going to be pretty easy because we already have the position of the center of that plane, its rotation, and basically that's everything we need to get started, right? So when the anchor is created, when we get that callback, we are going to want to create a new plane geometry and place it in our scene view. So we're going to get this anchor, set the type as AR plane anchor because we will be accessing the properties that only AR plane anchors have. We're going to create our virtual plane object with that anchor, because it has to be the plane anchor specifically. And we're just going to assign this plane to our dictionary of planes with a identifier provided to us by ARKit. And then we're just going to add this virtual plane node to our scene. And for debug purposes, I will just print out plane added. So this is what happens when ARKit updates information about our planes, because as the user moves around, the positions and rotations of the anchors are going to be updated, right? And we're going to want to update our plane geometries as well. So we don't want our cup of coffee to be floating around somewhere in the middle of the room as soon as the user just moves around a little. And then as soon as the plane disappears out of the view of the user, we're going to want to remove that geometry. So this is similar to the updates and adding functionality, but we're just going to remove this plane. Then we're going to handle the errors from the AR session, and we're going to.
The previous one, if you could just follow up a little bit. So, like, when you said that it's going to disappear, is that like when the user turns around, it doesn't follow you back, and then when it goes back to the coordinates, it again shows up?
It will not really follow you if you don't implement this method, if that's what you're asking. But for example, if the state is limited at first, and ARKit will try to estimate the position and the rotation of the plane. But then as it gathers more features from the camera, it's going to update the anchor accordingly. And we just want to catch that newer info, which is going to be more reliable, right? And we're just going to update our nodes accordingly so that they're not displayed at one position. I mean, it will just be a better position to place our anchor at. All right, so this is where we are gonna want to display the state of our session to the user, right? And we're just going to use our session status object. We're going to update it with failed, for example, because this is the error that's going to require us to restart the experience. That means it's the same as if our app had crashed. I mean, it didn't, but we just need to show the user that they need to restart the experience. So this error, it will be irrecoverable. At the same time, when session is just interrupted and not failed, we're going to show the user that they need to just move around a little to resume the experience. So we're going to update it to temporarily unavailable. So when that interruption has ended, so the user just moves around a little and gathers those new feature points, we're going to update our session status to ready again. So the next thing is we are going to handle is we're going to want to place our actual objects on the actual planes. And the way we do that is we handle user touches, and we need to somehow transform it to a 3D coordinate on that plane. So we need to do heat testing. And as I said, ARKit is going to provide that function for us. We just need to handle it correctly. We're going to use the touches began function to do that, but there are multiple ways that you can do that. So I will get the first touch that has been detected. I will check if my session status is ready, because I don't want to place my cup of coffee if the session status has been interrupted or if it had failed, because we're not going to have any data available. So this is how we do heat testing in ARKit. So we just need to call location in scene view method, and we're just gonna create our plane with that touch point, and we're gonna call the add coffee to plane method, which is so here it is. With that, I think we're done. Do we need to do anything else? Have we forgotten something? So I will just run this on my phone.
Yeah, I think there's an error.
Oh, right. Yeah. So I'll just hit the run button. Seems like I did not expect this. So we have started our experience, and we can see this origin right here. And we can see all of those feature points, right? So I think that is enough for ARKit to detect our plane, and we can see that the status is click any plane to place your coffee, right? So we can just click here. We can see this scout here. So if someone just turns off the lights, we're gonna see that the lighting is gonna be updated automatically. You can see it just became dark. Yeah, you can turn the light back on. We just needed to run one line of code to do that. And for example, if I cover my camera, it's gonna go dark as well, right? So if I do that, my session is gonna be temporarily unavailable, so we can see that all of those feature points are gone now. I have provided several USDZ models, so you can play around with them. But I have one that is actually animated, so just to demonstrate how easy it is to import your existing models into your AR experience, I'm gonna run this. Those are just the models that I have downloaded from the Apple developer website. You can go there and you can download all those sample models. I'm just gonna use this table instead. So in newer versions, not versions, but in newer hardware, you can actually do things like people occlusion, for example. So you can place virtual objects behind people, or if someone just stands here, the robot will become invisible, like it's going to be behind the person. But for example, if I just do this, obviously this does not happen. So you will need the iPhone 11 to do that, and you're going to need a little bit of more work to achieve that. But as you can see, it's pretty easy to get started with AR. So we just needed to basically set the delegate. We needed to create the configuration and create our scene, and the rest was just handling the state and updating the label to make it look nicer. So at this point, if you have any questions about anything at all about this presentation, happy to answer. All right, thank you.